All right, so now that we've got the item data in place and we've got the item class, which is going to be the container for all the item data, that's like a crucial step in moving forward to getting an inventory. But the next big thing that we need to implement is going to be the actual interaction capability on the player. So we could go ahead and make the inventory and start doing that stuff, but I figure it's better to do this because once you have this in place, then once you build the inventory, it's very easy to make a pickup or something in the world that you can test it all out with. And so I figure we'll go ahead and do this part. So the first thing I want to do is come down here to my classes, C++ classes, add import new class. And so we're going to be making an interface to create this interaction capability. The one thing I've noticed about this is weird. Normally, like, you have a couple of classes right here that it kind of like, there's a common, yeah, it says it right here, common. Usually I need to go here to find classes, but the interface is not easily found in that list for some reason. So if you just scroll all the way to the bottom, this is actually the one we're after right here, Unreal Interface. And so I'm going to make a new folder for this and call it Interfaces, just in case there's ever a need to make more than one in the future. So I'm going to select that. We've got public, private. Okay, that's what I wanted. And this will be called the Interaction Interface. Interaction interface.h looks good. Create the class. All right, and so once, let's see, well, live coding will run and get everything finalized. Once that's done and you see finished here, go ahead and close this. And we can actually go ahead and, do we need anything else in the editor? Actually, yeah. Before we close the editor, I'm going to make a test class that will let us test out our interactions on. And so this is just going to be an actor. What we're going to do is, after we build the interface and build the line trace capability on the player, then we can drag this actor into the game. We'll call it interface test actor. And we can override the functions on this guy that will let us test out our interaction. So what I like to do for this is anything that's an actor in the game world that the player will be interacting with, I like to make a world folder. This is where stuff like the pickup, the test actor, like if you made like a switch class where you go up and you can interact with that, I'd put stuff like that in here, and then obviously you can add subfolders later on as you want. I'm just going to put it right here in the top. Interface test actor, public, private, looks good, create. All right, this compilation's good. Done in the editor for now. Let's close this out. All right, and so you can see here, it's opened up our classes for us already. We don't need to worry about the interface test actor right this minute. So I'm going to close those. I'm done with item base. I had those still open from earlier. All right, so let's go to the header file of this interface. So in standard C++, at least to my knowledge, and someone can correct me in the comments if I really am wrong, I believe that an interface is going to be a class where you always have to implement all the functions that are provided in it. It's a way to standardize. Say you have multiple different kinds of classes that are technically unrelated, but if they all inherit from this interface, then that's a standard set of functions that you can guarantee they will all use. It's a way to guarantee that anything that inherits this will be able to have this function called on it. And so Unreal, it's a little bit different because you can kind of pick and choose. If you inherit from this, you have access to everything that's in the interface, but you can only implement what you need. So you'll notice there's two things here, which is a little bit different from what it typically does. It says right here, this does not need to be modified. I don't know the reasons for this, but it creates this kind of U version, like a U interface class. You don't touch this part. This right here, it's a, add your functions to this. This will be inherited to implement. So we're going to come down here and we're going to start implementing our functions. So when we think about interaction in a game, in most games, when you want to interact with something, you walk up, you aim at it, and something happens, whether it be a little pop-up, something highlights like the object itself, or some kind of effect appears around it, sparkles, a faint glow, whatever, or all of the above. So with that, you want to implement that into your interaction, and that would be like a focus, right? So you're focusing on an object, but you haven't done anything with it yet. So we'll call this begin focus. This will be one function. If you're not familiar with virtual, what virtual means, it's a way to establish that a function can be overridden by child classes. There's more to it than that, but for right now, that's what this implies. This is saying, okay, anything that inherits this interface can override this function and give it their own custom implementation. So if we have a begin, we know we also need an end focus. Then once we are focusing on something, now we say we push E or whatever our interaction key is. So now we want to actually begin our interaction. Now we could just do interact by itself, but I'm going to implement timed interactions. So it's very common in games. You walk up, it's like hold button to do something, like a door, or a container, like hold E to open, and it waits like a second or two. Using a begin interact and of course an end interact, you can establish a interaction time, and in the begin you can do some checks for that and say, okay, is the interaction time on this object 0? If it is, just interact. Otherwise, we start a timer and we display some feedback to the user, and once this is done, then we can call interact. And obviously, like I said, if the interaction duration time is 0, then you just call interact directly. So it's just a way to kind of build this in on the front end, so we won't have to go back and add that later on. Now, this is the last thing we're going to need is, I'm going to call this, it's a struct called f interactable data, and I'll just label it interactable data. So we don't have this now, so we're going to build it. So we can come up above here, right under the includes, and start building this. So it is a ustruct f interactable data. We need the generated ustruct body, and now we're gonna build a constructor for this thing. I've got one of my A key is messed up, so a lot of times I try to type an A and it types like 2 or 3 on my mechanical keyboard. I have to replace it. Okay, so here's our constructor, and you can leave it like this. It's just a default constructor that doesn't do anything. I'm going to come back to this in just a second. So first we're going to add our fields. So we want an enum that will be the type of interactable. So actually, let me go ahead and build that as well, because if we're going to use it in here, we might as well. So uenum. I don't need that. Again, in my reference, I must have thought at some point I might want to use blueprints, but there's no point because there's no blueprint usage in this. So e interactable type UN8, and I talked about this in the video where we built the item data structs. It's just forcing each of the items contained in here to be the size of a unsigned integer, an unsigned 8-bit integer, so 1 byte. So the different types of enums, the different types of interactables are going to be pickup, non-player character. Again, we're not implementing this, but this is all the stuff I built in when I made this because I'm thinking ahead of what kind of things I'm going to interact with, right? A device. And then a device, I called it this because I was like, okay, I want to be able to interact with like a door, but I also want to be able to interact with a gate or a window or anything like that. And I thought, okay, device is kind of a good word that sums all that up. I don't want to have, I mean, I guess you could technically have an enum for every single thing, but I was thinking of it as like, okay, I'll have a single class that can perform all these different actions. So if I make one class that's movable in different ways, then it can be a door, a gate, a rotating door, a swinging door. It can do all this in one single class. And so I called it device. The other one, along the same lines, I called it a toggle. A toggle would be anything like a button, a switch, something that you like a lever, right? Anything that is used to activate a device or activate some other functionality. So I called that one toggle, and then lastly, container. So let's add in our umeta display name. Need the comma to go after that. I'm going to come back and fix this in just a second. Okay, so there's our interactable type. And so come back down here to our interactable data, and we're going to create an interactable type and just call it interactable type. We also want a name. We want an action. We want a quantity. Now, one thing I will say real quick, if you are using Blueprint and you want to do that through these tutorials, that's totally fine. You will have to use int32 for everything, because in C++ you can use some of these other types like int8, uint8, etc. But if you're in Blueprint, it only supports using int32. So I just figured, an int8 can go up to 255 because it's 8 bits. I didn't think that I would need more than that for a quantity, so that's why I went with that. It really doesn't matter too much. You can make it a 32. The last thing we want is the interaction duration I talked about. Okay, and so let's make these uProperties. Now, this is defining what the struct is, right? And then we have one that travels along with the interface, but we're not going to be editing this one directly. What we're going to do is we're going to create another one on like a device class or something, or a pickup. We're going to set it, and then we're going to take that one and set it equal to this. It'll all make sense later, but essentially the reason why this is edit instance only is because for anything that inherits this interface, it's going to get its own copy of interactable data that's set according to that instance. So all of these should be edit instance only. Quantity obviously is going to be only for pickups. And then I put a comment here, used for things like valves, like if you turn a valve wheel, doors. So now the last thing I want to do, and I mentioned I would come back to this constructor, I'm going to use what's called a member initialization list. So if you ever see this format in C++, what this is saying is when the constructor runs, I'll do the first one here. When the constructor runs, we'll make it pick up by default. It is going to do this stuff. I think it technically happens before the body of the constructor. What I mean by body of the constructor is the constructor still has code, that it runs in its brackets, right? That's pretty common. But this stuff, I believe, happens first and then the body runs. And so I'm going to indent this to keep it clean. And it's got a squiggle here because it's saying, okay, hey, you've got other things in here that are not being initialized. So I'm going to add those. So the name is going to be ftext. There's a nice function in the ftext class called getEmpty, which is just going to return an empty string. Again, same thing, because we are going to override all of this and set these values, but we don't, there's no reason to do that right now. So they can all just be initialized to be empty. Quantity 0, and then interaction duration 0.0 f. And then you don't need anything after, just the brackets, and then the semicolon closes that off. And so there you go. So now if some reason comes up where you do create one of these, by default, it will have all of this set already, and then it can be overwritten. All right, and so this is actually, I don't know if you have to implement these functions. We'll try it, and if it fails, we'll come back. I think just by doing this, what we have here, it allows you to now inherit this and then give this an implementation in whatever class. So we may have to revisit that, just add empty implementations, no big deal. Okay, so now here's the next crucial part of this. What we need to do now, so I'm back in the character. In the character, we need to add the ability to shoot a line trace and check and see if we've hit something that is interactable. We can do that using the interface, leveraging the interface. We can say, okay, line trace hit something, now check and see, does that thing implement the interface? First thing I'm going to do is I'm going to clean this up. It irks me really bad when there's multiple sections here, like a protected and then another protected that are this one's gray because writer's smart enough to tell you like, hey, this is pointless, it's not doing anything. So I'm going to get rid of that. I'm going to get rid of these. I'm going to move them up. I'll just keep them in public because they were in public. And this is all the default stuff that was in this in this class, by the way. These guys, the actual variables themselves, can go back down to protected. These are just the getters for those. Turn rate doesn't really need to be public. Let's see. I'm gonna fix all this up. Let me go find the item class because that's where I have these. You saw in the previous video, I really like to do this because it just cleans everything up so nicely and keeps it easily readable, other than having this giant massive list of just stuff that blends in together. Okay, so now we can move our, okay, no, these are getter functions, they're good. Move this guy down. Clean it up, all right. And do the same thing for the protected section. Turn rate, functions, everything down here is a function. Nope, not these, okay. Okay, again, completely up to you if you like to do this or want to do this. It's just, I find that now it's so readable, right? Here's my public section, variables, functions, protected, variables, functions. Okay, so there is a special class that the engine provides you called the TScript interface. What that is a you can kind of think of it as a wrapper for interface handling, but it makes it extremely simple to check if something if something inherits that interface, and then call the functions. So we need to, it can be protected, and it is called T-script interface. It needs a type, and the type is our iInteraction interface. That's the one that we just built right here. And then now I'm just going to call this target interactable. I'm going to make this a uProperty, visible anywhere, and it's in the interaction category. Oh, I don't think I talked about this already, but basically in the editor, if you do this, you will have to find the interaction category, which will then be, it'll be alphabetically sorted. I really like this trick that I don't even remember where I found this, but if you do something like character and then the vertical bar, it will make this a subcategory. So now you will have character, which is, C, so it's closer to the top, easy to find. You expand it, you'll then have an interaction category where this stuff will fall into. So really useful. I don't think anything else has a category to fix, but we'll be doing this from here on out to keep keep everything nice and clean in the editor. Okay, so to go along with the interaction, I built a little struct that will carry a few crucial pieces, and it doesn't have to be a struct, they can be separate, but this way I thought, it's bundled together. You're always calling, it's called it's called F interaction data. And so this is different from interactable data, right? Interactable is like an object or an actor that we're going to interact with. Interaction data is like info about the interaction. And so ustruct body. So what it's going to contain is it's going to contain the current interactable, and then it's going to contain last interaction check time. Because what we're going to do, the line trace is going to be controlled through the tick in the character, but you can control it by saying, what is this, what is the duration? How often do you want it to happen? And so we're storing that in here, and then we're going to do a check and say, okay, if we're over this elapsed time, shoot another line trace. Because there's no reason, it's not really necessary to shoot it every single frame. That's too much. So it makes more sense to kind of space it out a little bit. And then this one is also a uProperty. And I am going to put a default constructor in here. Man, it really freaks out. It like finds, when you start typing, it finds a million things in that autocomplete. Current interactable is going to start off as a null pointer. Last interaction check time is going to start off as 0.0. And then put the brackets. There we go. Okay, so this is different from our target interactable, because target interactable means like this is what we're hitting and actively processing through the line trace. This one is kind of like the one that we have stored, saying like this is the one that we just found, and it allows you to check and see if it's valid, or say like if it matches. You can say like, okay, if we just found something, we can check and see, does this match the current interactable? So it's really useful for that. All right, so those are the crucial pieces of data to start with. Now we're going to need some functions. And I think, yeah, we're going to need a couple of variables too. All right, so we want a interaction check frequency that I talked about. This will be in seconds. We want an interaction check distance, This is used to determine how far the line trace is going to shoot out from the character. And then we're going to want the timer. So let's see. To make a timer, you start by doing F timer handle. And we're going to call this timer handle interaction. Oh, and we also, let's see. All right, so Rider does this for you. I don't really like this, but it already included my interface header for me here. I would have to come up here and do this anyway, but we need to include this here because we need the definition of our interactable data. I am usually not a fan of including headers in headers because that's how you end up with a circular dependency. If you're not careful, obviously. Class A includes the header for B, B includes the header for A. You will get that causes a problem. And so I usually try to always include headers in the CPP file because you don't include it's only including it where it's going to be used, basically. Anyway, the point is, I can talk about that more later if it comes up. But basically, we need to include the interaction interface header here because we're also going to have our interaction data. So the interaction interface, it's for this definition, but then we need the interaction data struct that we just created. I was misreading it because the names are kind of similar. Okay, oh man, the A's. Okay, so this one is what I just built up here, this struct, right? With our current interactable and our last check time. That's this. And then the timer handle we're gonna use to actually create a timer for the interaction. Now we need our functions for our interaction. So I'm gonna move this default stuff down. We need something that's gonna be called every tick to shoot the line trace. And so I called this one perform interaction check. We need at that point, all right, so a line trace is going to shoot, it's going to see what it hits an actor, it's going to check, does this implement the interface? If it does, then we're going to call found interactable. This is going to take in an A actor, new interactable. However, if we don't find an interactable, then we call no interactable found. We also want to have begin interact, end interact, and oops, speaking and typing what I'm speaking, interact. Now, these are different from the one in the interface. These are, you can think of them as the main one, right? Because this is like coming from the character. So this is the action of interacting. Then when we're implementing this on something, this is the one that's going to be called when you interact with it. So that's the difference here. These are the ones, this is the acting on, this is the one that is receiving that action. All right, I think that is it. We got our timer, we got all the core functions, we got the variables. So now I'm going to implement all of these. This is a feature that I really like with Rider. You go to generate definitions by declarations. It sees all these and it's like, hey, you haven't implemented these yet. Make sure they're all checked. Bam. Now, the one thing that's annoying is that it doesn't always put it into a logical place. So I want these turn and lookup functions to be put back down here with the move stuff. And now, here we go. I also am missing tick. So if you're missing tick, so a character class inherits your character class inherits from the main character class, which has tick in it. So in order to get tick back, all we have to do is you can either go to this class, find the definition, and override it, or if you have a ability to override, I think Visual Assist in Visual Studio does this as well. Search for it, and let's see, add tick, remove tick. That's not what I want. Tick. Here's the main tick right here. So I'm going to override that, and see it does this thing again, puts this down in its own public section. And all these generated comments. I know that they were probably helpful at one point, but it's just so much extra stuff. Okay, so we're in protected functions. That's our stuff there. All right, so now tick has its override. Oh, and when I said I would talk a little bit more about this in the interface, so virtual means something can be overridden. It simultaneously means something is being overridden. So obviously, like I said, tick is implemented on the character itself. If you override that and you put it into your child class, you also designate it as virtual, but then you designate it as an override. I don't know the reasons behind that. It's probably something in the C++ standard, but that's just that's just how it's done when you override functions. So we will then generate our definition for that. And at this point, we're ready to start adding code in here to the actual CPP file. So, and leave this super here because there's stuff that happens in the parent tick that we want to still happen. And you can go to the definition and look at it if you want to, but that should be left. Okay. So the first thing I'm going to do, the perform interaction check is the most crucial function here. So this is the one that's actually creating the line trace. And when I say creating, I mean we have to figure out where we're going to start it from and where we're going to end it. And then this will tell us, it's going to check for the interface and set the target interactable that we created. So the first thing we're going to do, we're going to set in our interaction data our last check time. This one is going to be get time seconds. Okay? Because like I said, we're going to come down to tick, and let me move this actually. I want this to be just my personal preference. I like tick to be right up at the top near all the setup stuff. And you know what I just realized? Begin play is also missing. I don't know why these were missing. All right, oops, we need our begin play for sure. Move this up, put it next to tick. There we go. Get our definition. It obviously put it in a weird place. I'm gonna put it up here, right above tick. Okay, we're gonna need that for later on when we set up stuff. Okay, so we're setting our last interaction check time, which we're gonna use in tick, by getting the current world time in seconds. That's basically it'll start counting from the time you press play, I believe. So now we need to make a couple of vectors. So we're going to make a vector called trace start and initialize it with a 0 vector, because basically we just need to create these and then we're about to set them. Oh, you know what? Actually, I'm probably going to refine this later. But in my game, the one that I'm kind of referencing, the reason I did this is because I have an aim mode, and based on whether or not I'm aiming, the vectors are set to different things. We're not going to do that right now. Again, I'll probably come back and do it. It's not the main focus right now. But before I delete this, if you're not familiar with this syntax, these brackets here, it's just another way to initialize a variable. And I believe it's a little bit more performant than creating it and setting it with an equals, it's probably negligible, but one thing that it is useful for is it guarantees that the type will be this type. So like say with an enum, enums can be casted to an integer. And so if you want your enum value to be explicitly initialized with an enum, you can use these brackets and it will enforce that. And it'll be like, you know, if you said you had an enum here and then you tried to say like, I want my enum to be 1, it will cause an error and it won't let you do that. So that's just something I guess kind of neat about the bracket initialization. All right, so the reason why I got rid of that is because since we're not doing an aiming mode right now, the trace start is going to be get pawn view location. And what this is, when you create a character and it has like its collision capsule that's like human size, it automatically is initialized with a certain value that represents like the height of the eyes. So we're going in and it'll return that to you as a vector. And so that's what we're going to use there. We're going to do trace end, and trace end is now going to be trace start plus get view rotation dot vector times interaction check distance. Now what's going on here is it's going to essentially, so the view rotation comes from the character controller, not the player pawn mesh, because you're changing your view with the mouse and you're changing the location of the camera with the mouse in a third person character, right? So based on the rotation of that, and then you can see here, look, it tells you get the view rotation direction, the direction they are looking, which is normally controller rotation. That's what I'm talking about. So whichever way you're looking, it's going to take that rotation, convert it into the forward vector of that view, and wherever that's at, we're going to multiply it by the distance that we want to kind of trace out to for interactables. So we've got our two traces. Now we can go ahead and get ready to do the line trace itself. So to set up a line trace, you need to create f collision query params. This is basically, it's a struct, so just call it query params. The query params contain some useful things for doing line traces. So you can see here, use complex collision, find initial overlaps, etc., etc. A bunch of different things you can set, masking, all kinds of useful stuff, right? But we don't need to get too far into that right now. What we need is we want to call add ignored actor and pass in this pointer. That's just saying, since I'm the class shooting out this line trace, I don't want to hit myself with it. That would be a little bit ridiculous. The next thing we need is an f hit result trace hit. So this is another struct, but this struct is used to store the result of a line trace. So see, it contains information about one hit of a trace, such as the point of impact and the normal and etc. What we're using it for is it also contains the actor that you hit. Now we're ready to actually call it. So it's get world line trace single by channel. The first argument is, so right here when it says out hit, what that's saying is the ampersand is we're passing in our hit result by reference. This function will modify it, and then that it becomes the output. So right after this, if it hits something, it will be stored in trace hit. So line trace single by channel. Let's see. Oh, got confused here. Trace hit, we're passing in first. Now we need the start and the end vector. We already have that. Trace start, trace end. Then you're passing in the collision channel. So we're passing in the EC, it's called ECC, which stands for E collision channel visibility. And then the last thing is, you can see, put my comma back, is it wants, so here's the channel we pass, then we need our params. And since we already have that, we pass in query params. Now notice we put an if here. The reason is because if you look, returns true if a blocking hit is found. So usually that's the best way to implement your line trace, because it gets the return and checks it all in one call, right? So now if we have a trace hit, we're going to find the distance. Oh wait, sorry. The first thing we want to do, so after we found a hit, now we need to actually see, does it implement our interface? So if trace hit, and you can call it get actor, get the class of that actor, implements interface, and now what we're going to do is, it wants the class here. So you pass in U interaction interface static class. That's just a syntax that lets you return. Why is this mad? Oh, I forgot my other parentheses. The static class, this is like saying return the C++ class itself. I'll talk more about this later when we're creating UI elements, because it actually is something that can trip you up. But basically now we're getting the C++ class of the interface, and then it can check and see, is this actor inheriting it? So now if this is true, now we know we found something we can interact with. But we're still going to do a couple of other checks. So distance is going to be the start of our trace minus the trace hit dot impact point, and then we're going to get the size of that distance. This will, because remember, we have a interaction check distance, because we don't want people to be able to, you know, if the line trace hits something, but you know, I don't know, I guess technically if the line trace is only as long as the interaction check distance, how is something ever going to be longer than it? May actually be able to completely remove that. But since I have it in my reference, I'm going to leave it for now. I'll do a little bit more checking and maybe mention that again later, define it. So we've got our distance, okay. So now we're going to check and see, okay, is this actor equal to our interaction data current interactable? Or sorry, is it not equal to? And a lot of people have asked me about this. So I have a font here that uses what's called a ligature. So don't be alarmed by it. It's just nice looking, but it's actually doing an exclamation and an equal sign. So yeah, if you want to know, I can mention. I'll probably put this in the description of this video, where you can go to download this font and stuff like that. But if your editor supports ligatures, you can turn that on, and then you get nice symbols like this. Okay, so if we are not looking at the same interactable, and our distance is less than or equal to our interaction check distance, now we call found interactable, and we pass in the actor. We're then going to return, just because after this runs, we don't have anything else to do because we found one and we handled it. Now, if this part fails, then we're going to say if our actor is equal to our current interactable. Just return, because basically at this point it means we're still looking at the same interactable, and we don't really need we don't need to do any other logic. We just need to maintain the current status. Now, if all of this falls through, or if any of these fall through, right? So if the line trace doesn't find anything, if it doesn't implement the interface, and etc., we want to call no interactable found. Now, you may have noticed that these return statements were grayed out because it's essentially saying like, hey, there's no point to this because down here it just ends. Well, now there's a function down here, so execution could stop here now or here, or it could go all the way down here. So I don't know if Visual Studio is smart enough to do that for you or not. But anyway, so this is the core of it. This is our perform interaction check function. Now what we can do is we can, let me see, where is this timer set? Actually, the timer is not being used for the interaction checks, just the interaction check time. So come up back here to tick, and we're going to put in the actual ability to call this. So if it's another function through get world, time since, get the interaction data, last interaction check time is greater than interaction check frequency, you may have guessed we will call perform interaction check. And now we should test this out real quick just to make sure it looks good. This is everything you need to constantly, be performing your interaction checks at a certain interval. Now, interaction check frequency has no value right now, so let's come up here. I'm going to delete their little helpful informational comment. I'm going to set mine to 0.1. 0.1 seconds. You can set this to whatever you want. You can set it less. Just keep in mind that I believe 16 milliseconds is one frame. That's how fast tick is running. You don't need to be setting it lower than that. It really won't have any point. I believe I read that something below that, it'll just kind of ignore it and you'll just still get it once a frame. Don't quote me on that, but basically, if you think about it, unless a player is whipping the mouse around between a bunch of different interactables all the time, 100 milliseconds is fine. It's pretty much like not noticeable, the delay between finding a new object. Interaction check distance. So this one is something that you can just kind of tweak to your liking. I use 225 for mine, which is, I believe the player character himself is like 200 units tall, so it's just a little bit longer. Again, just kind of tweak it. We're going to test it here in a second, and you'll see how to tweak it, and then you can come back and you'll see how to visualize it, and you can come back and tweak it to your liking. Let's see, is there anything else I need? I think that's good. So now what we're going to do, I said we're going to visualize this line trace. So how are we going to do that? There is a include you can use. Again, with my style of organization, I like to kind of just put some labels here. Game framework is engine stuff. Capsule component, input component is engine stuff. Camera component. Okay. There's an include that is draw debug helpers. Oh, geez. So in draw debug helpers, there's some really nice functionality that lets you, it does like a debug line trace. So it's very similar to what we're doing here, but it doesn't, you don't have to worry about all this, like the channel and all that. It handles all that for you. And so right here, after we actually no, it's separate. It's separate from this, right? All it requires is a start and an end. So what we're gonna do, we're gonna draw a debug line, and if you look right here, there's quite a few things. You can draw like a whole bunch of stuff. 3D text, I didn't even know that. A frustum. Frustum is like the view of a camera. So like the square view of like a camera lens looking out. So this is all pretty cool. Crosshairs, interesting. All right, anyway. So line is what we want because we want to visualize our line trace, right? So it needs a world. So it's just get world. Now it wants a start. And so we have a start as trace start. It wants an end, trace end. It now wants a color, and so I use red. So to find that, it's a struct f color, and then you got all your colors here. You can pick whatever you want. Red. Now we need a what is this? Persistent lines. I think that's basically saying like they will never disappear. So false. And then the lifetime, I'm using 1 second. And let's see, death priority thing. Okay, so this other stuff has defaults here, so you can actually leave it. Let's see, wait, what was it? It is, oh, thickness. If you want, you can make the line a little bit thicker. I think I will. So death priority, just leave it at 0, and then thickness, I'll make it 2. I believe it's gonna be pixels. All right, so let's go ahead and build and launch and go try this out. Okay, so I started building, and sure enough, I don't know if you remember earlier, but I said, oh yeah, in this interaction interface, I don't know if you actually have to provide implementations for these, but I might have to come back and do that. So sure enough, since I haven't built until this point, what this is saying, so anytime you see unresolved external symbol from your compiler, that is from the linker. So building actually goes in different phases, right? You have your compilation. We can really just kind of sum it up as compilation and then linking. So compilation is like checking the syntaxes and types and everything. Linking is where it actually goes and tries to connect up implementations with the declarations. And it's saying now, this looks like a bunch of gibberish, but what it's saying here is like, hey, I need an implementation for begin focus, end focus, interact, and all this stuff. So link 1120 is the error code, 5 unresolved externals. So thankfully that's really easy because we can generate all of these definitions here. And sorry for those of you who don't have the ability to do this super quick. Just go ahead and knock it out, one at a time or whatever your method is. But now, since I've given these default implementations, even if they're empty, now we can do the build and everything should be good. All right, so I'm back in the editor, everything built. I am going to press play, and what we hope to see is that right there. We've got our nice little interaction line trace. Now you'll notice it's coming out of his neck. We could probably fix that by going and try to figure out how to tweak the eye height I talked about, because it's what was it? It's get pawn view location. Let me go and look at this function real quick. Yeah, see this right here, get actor location plus, so that's at his feet. That's like at the bottom center of the actor. Plus, we don't care about X and Y. We want to raise the location by the base eye height. I'm pretty sure we can change this and just kind of tweak it up a little bit. It doesn't really matter. Let's see. Yeah, it looks like I did do that. I don't even know what's the default. There's probably a default somewhere. Oh, nice. I was able to find it doing this. So here's in our pawn.cpp. It's setting it to 64. I found in my experimentation that raising it up about 10 will keep it from coming out of his neck. But again, this isn't going to be seen by anyone, so this is purely a matter of like how much this kind of stuff irritates you. If it doesn't at all, then don't worry about it. But if you want to tweak it, what you would do is you would come back in here, come back into your constructor, and it's a public. It's public, right? So you can essentially override this directly without having to use like a getter or setter. And you would just say base I height equals. So we saw it's 64. Just try like 74. All right, so now if it's coming out of his neck, let me recompile and see what that looks like. Okay, so I guess, like I said, doesn't really matter that much. This looks a little bit better now. The way that I interpreted it, the reason why I did all this is because I was like, hey, you know, I want it to be based off stuff my character can see. And so I just thought it needs to come out of his eyes. And so I don't want it coming out of his neck. I want it to be like, when I'm moving the camera around, I'm kind of moving my character's point of view around, and I don't know. It's fine. Either way, now you know how to tweak it if you want to. But the point of this is our interaction line trace is looking good and it's working. Now, I'm talking all about how I want it to come out of his eyes and it can shoot out the back of his head. So there isn't actually an easy way to fix that, which I did fix because I was like, okay, in some games, it probably doesn't matter. And if it doesn't matter to you, then it's fine. But say you're standing like this. Does it really make sense to be able to interact with something behind your dude? I mean, okay, it's not a big deal. If it doesn't really, it depends on how casual you want your game to be. But for me, I was like, nah, I want the players to have to face things and like interact with them. So you can use a dot product to actually fix that. So if you come back into our perform interaction check function, where we are doing the line trace, before we ever even call the line trace, before we ever even call the debug line, I'm creating a float, and it's called look direction. So look direction, again, you can use the brackets here. We're going to use the dot product function in the f vector class, and what we're going to pass in is get actor forward vector, because see what it wants is it wants two vectors, an a and a b, and it's going to get the dot product of that. So dot product is a way to check if vectors are pointing in the same direction. So we're going to get our actors forward vector, and then we're going to get our view forward vector, and we're going to say, okay, oh yeah, okay. So it's returning a double. Interesting. This is what I was talking about with the brackets here, right? It's going to force a type. So it thinks, because it must be something to do with the way dot product is calculating. It says it returns a template, but it thinks it's getting a double, and so it's mad here. It's like, hey, you know, you're trying to initialize this float with a double. So good. I'm glad this happened, so I can show what I was talking about earlier. All right, it's not a huge deal. I just try to use the vectors when I can, but it's fine. All right, so now we've got our dot product of these two, right? So where our pawn is facing and where our view is facing. Now, what we're gonna do is we're just gonna check if look direction is greater than 0. Because the way the math works is based on if it is positive or negative, that determines if the vectors are pointing in the same direction or if they're pointing away or perpendicular. Anything positive means that they are pointing in the same direction. And so negative would be they're pointing in opposite directions, anything negative. And it goes all the way from like 0 to -1, and I think from 0 to +1. Now, this is saying if they're pointing in the same direction, then you can do all of this. And so I'm going to wrap that in brackets. And oops, I missed my debug. Move this down just a little bit. There we go. Okay. So now we're not even going to ever shoot a line trace at all unless we are looking in the same direction the pawn is facing. Now again, I said it already, but if you don't care about this, don't worry about it. Just skip this whole piece. It's not going to affect anything. All right, I'm going to stop my editor and recompile and test this out. All right, so now you'll notice, okay, it looks good. We're looking ahead. We're looking where the character can see. But now what if we're like, oh, you know, I want to trace and interact with this box here. Well, look, the line trace is stopped. Now it starts 0 or anything very, very slightly above, even if it's like 0.001, is considered valid because it's kind of like it perpendicular almost. So you can see it doesn't seem to be, it's like when I aim right about here, it starts. So it really does represent your character's field of view really well. And so I kind of like that, and that's what I that's why I decided to do that, is because I wanted it to be like my character's field of view. Oh yeah, of course. The dude's turned a little bit. That's like his stance. So yeah, of course it looks a little different on this side. But yeah, it's going to be, I believe it's going to be 90 degrees. And there are ways, you know, obviously we could tweak that. If you wanted it to be more narrow, you could come in here and raise this and say if it's greater than 0.1, right? That would be kind of like narrowing the field of view. But I think this is fine the way it is. I'm just going to leave it at 0. So, sorry, I said 90, but what I meant was 180. 180 directly to the character's left, all the way over to the character's right. So there you go. Now we can start adding in the functionality to actually set our target interactable and get ready to call the functions and implement them on the other class. All right, so perform interaction check is looking good. And so now we're going to move forward and fill out the rest of these functions. So let's see. First, I'm going to clean up some of this. I don't need these helper comments. We're going to add in a function here. This one we want to be public because other classes need to be able to get this. So it's a force end line, returns a Boolean, and it is called is interacting. And I'm sure you can guess what it's going to do is it's going to return a value based on whether or not we are currently interacting. And so that value will be determined by the timer. So It's const because the function itself does not need to change anything. It's essentially a read-only function. And what it's going to return is get world timer manager. I think it's is timer active. And what we're going to pass into it is our timer handle that we made for interaction right here. Now, this will basically, right, if there's 0 interaction time, this doesn't really matter. This is going to be more used for if there's a timed interaction going on. So needed to make that because we're going to fill out found interactable, and for that function, there's a little bit of checks and stuff we want to do at the beginning. So assuming we did a line trace, we found something that implements the interface, and it's now our new interactable. What we want to do first is we want to use the function we just made. If our character is interacting, we want to call end interact. Because, you know, we're basically looking, it's like that would imply that we've found something new, right? We're not going to get into this function at all unless this part is true, which is the current hit actor is not the same as our current interactable. So this would imply that we already had an interactable, something weird happened, and we just now found a new one in the middle of the timed interaction. Next, we want to say interaction data, our current interactable, if there is one. All right, so the very first time, or I guess when we implement no interactable found, I think we null this guy out. But for right now, this is implying, okay, there is one already. If we have one, we need to set our target interactable to our current one. The reason being, this is how we call the interface, right? So then we want to call target interactable end focused. So that'll end, the focus is going to be used, like I mentioned before, to like highlight or something like that. And so we want to make sure that we are ending the previous interactable if we have something new that's not the same. And then at that point, we can now take our interaction data, current interactable, and we can set that to our new one. And then we can use our interface interactable and set that also to our new one. Then we call target interactable begin focus. So that's a pretty simple function. We're just making sure that the previous stuff doesn't interfere with the new stuff, right? This is all just checks on the previous interaction. Okay, so we want to begin focus there, but now what about if we don't find something? If we don't find something, it implies we either didn't hit anything, we did hit something and it's not part of the, it doesn't implement the interface, or it's the same, it's outside the distance, or yeah, this one's for if it's the same. So if it's the same, then we should just end up here. Okay. But then again, no, if it's the same, it just does nothing. So it's basically if it fails the line trace or if it's not part of the interface. That's really when it's going to come here. All right, so say nothing is found. We want to check is interacting. We want to get the timer. So okay, so nothing is found. If we are currently in the middle of using a timed interaction, we're going to get the timer manager. We're going to clear the timer for our interaction timer handle. All right, so that's pretty standard. Now, again, we're going to do this exact same kind of thing. If our current interactable is valid. Then we want to check is valid on the target interactable dot get object. So the reason why, so here, go ahead and do this part. Target interactable end focus. The reason why this is necessary is because with pickups, the way the code's going to be implemented is when you pick something up, you go through a whole bunch of calculations in the inventory to check, you know, do we have enough weight capacity for it? Do we have enough inventory slots for it? We adjust the quantity, we add it to the inventory array, we add everything, you know, all that stuff. Then it returns a status that says, okay, this is how many items you added out of this one's quantity. If all of them were added, then the pickup itself from the world needs to vanish. So you call destroy on it, which is a way to just say, you know, delete this actor. What I found through my debugging on all of this is that there's times when destroy happens before this. So what would happen is it would destroy the pickup before it was able to process that this interactable was gone. So it would try to call in focus and cause a crash. And so this is just a very simple way, you know, and the weird part about it was, though, it didn't happen consistently. It's just one of those things where the timing, you know, the order of events is not always guaranteed in the engine, I guess, with certain things, and this is one of them. So by doing this, we basically remove the capability for it to crash our executable, because now if destroy happens and that actor is null, target interactable is technically null at that point, and we try to call in focus on it. Well, we're not even going to get here because this actually will happen properly, you know, and if it's not valid anymore, this is skipped and it doesn't really matter because the interaction is going to end anyway because it's gone. Here, we don't have this yet. This is something I'm going to set up next, but this is where we would hide the interaction widget on the hood. And so just putting a comment here as a placeholder, we'll come back and fill this in. We now want to get our interaction data, current interactable, set it to null, and set our target interactable to null. All right, so that one's also pretty simple and straightforward. So now we have our begin, end, and actual interact. So with begin interact, you'll notice that there's no focus, right? Because the character doesn't get focused. The focus happens on the other things. This is kind of how I said that, like, these are almost like the origin of the interactions. The interface is the result of the interactions, what's happening on those other actors. So when the character begins interact, we're going to perform another interaction check. And this is mainly kind of just a fail-safe to make sure that nothing has changed, right? Because say we basically want this to come back that we're looking at the same thing, right? Because as I was just looking at, if it's the same thing, then it just returns, right? So it's kind of just a quick check here to say, you know, verify nothing has changed with the interactable state since beginning interaction. Because if it has, if it's somehow, you know, and like I said, it's just a fail-safe. It doesn't really make sense that this would happen, but if somehow it did, then this would catch it and we'd go back, right? We'd kind of go back in the process. All right. Now, if interaction data, current interactable is valid, right? Always good to check this. You'll notice we check this in every single piece here because it can just, like I said, this type of thing, just in case stuff happens, you want to make sure you're avoiding crashes. If it is still valid, and again, this check, if our target interactable is valid, then we want to begin interact on the target interactable. And now we're gonna now is where the timer actually comes into play. The timed interaction is gonna come into play right here. So what we're gonna do is we're gonna use a function in the fmath class called isNearlyZero. And what we're checking is, remember we built in the interactable data struct here, right? We're checking the target interactable data interaction duration. We're checking, is this nearly zero, but we're going to give it a tolerance. So the second argument here, let me go back. The second argument on is nearly zero is an error tolerance. Maximum allowed difference for considering this as nearly zero. We'll put it 0.1 float. Now the reason for that is 0.1 is really fast. That's what our line trace is being shot out at 0.1 second, 0.1 second intervals. With a interaction time that short, it's really kind of pointless. It's like, why even bother? It doesn't add anything to gameplay. Even 0.2, honestly, even 0.3 doesn't really matter. But those are at least long enough to kind of recognize that, I don't know, you can make it like, if you want to turn a doorknob, you could kind of put in a little delay. And maybe that's when you'd use like 0.2 or 0.3. But I'm going to go with 0.1 for now. Tweak this to as you want. If it's within 0.1, then we will just immediately call interact. Because as I said, at that point, it's like it doesn't, if this is true, then you're saying, okay, I don't want to consider this a valid delay. Otherwise, if that is false, we're going to get world timer manager, set timer, and now there's a bunch of different overloads. That's what all this is popping up. A bunch of different overloads for this. What we're going to use is the one where you pass in a handle, you pass in a class, I believe it's this one, pass in a handle, a class, you pass in the function, and then you pass in the rate. So rate, it's a little bit confusing. When I first started this, I was like, this seems weird. Why isn't it called duration? Rate is like the duration. That's like how long the timer is going to run. So right here, when you see float in rate, that's what that's talking about. And then the last one is a Boolean here for whether or not you want it to loop. All right, so we're going to pass in timer handle interaction. Now there's a bunch of arguments on this, so I'm going to indent to the next line. And if you're not familiar, C++ is fine with line breaks, especially with like function arguments and stuff. So now we need the class. So the class is just this because it's the player. Now we need the function. So what the function is, a CS tutorial character interact. And now this is the function that's going to be called when the timer expires. Now the rate, see, and this is writers showing me, hey, this is the one you're on. How do I pop that up again? Yeah. So it should highlight, it's highlighted, but it's hard to see. But basically now it's kind of made it bold, float in rate. So we're on rate now. And I'm sure you have an idea. The rate we want is our target interactable. Well, it's just this. Copy paste this. The current interactable duration that we've gotten from the target interactable. And now, do we want it to loop? False. That's the last argument. So there we go. If there is a valid delay above the error tolerance that we've set here, we're going to start the timer, and as soon as that timer's done, then we interact. And that's all you really have to do to implement a timed interaction. Now, the graphical part of it is going to be a little bit more complicated to show on the screen, something like a progress bar. But this is how you actually handle the delay. Just start a timer. All right. So that's pretty easy. Now, end interact. With end interact, I'm gonna go up here and take a few of these things it's pretty simple. Pretty similar. Sorry. Trying to talk and do stuff at the same time. My brain doesn't always go the same speed as my words. Okay. So we want to, again, at this point, we don't really need to check if we are interacting, because if we're ending interact, right, we assume that it's time to clear this stuff out. So go ahead and call clear timer on the timer handle. But we do want to check again that the target interactable is valid. So I'm putting that there. Target interactable, now we just end interact on the target. And lastly, interact. So again, this is assuming, right, we finished our timer. So we're going to clear that timer. And then, you guessed it, we're going to check that our target interactable is still valid, and then we're going to call interact. All right. So that forms the core of the interaction system in this. We've gotten everything handled, and it was all relatively clean using this target interactable TScript interface class, right? This thing. It handles a bunch of stuff behind the scenes for you to make this very easy, right? Because now we just call these functions right on it. And anytime you find a new interactable, it's set to that. All right, so how do we test this out? So if you remember, when we first started this, I had us create a interface test actor. So this is completely untouched still. So now we want to be able to test our interaction interface, and we want to be able to see, how do we implement this stuff moving forward if we want to make a custom actor, right? Because if you want to experiment, you can feel free to add more actors and stuff that implement this. So it's pretty simple. Open up the header for the interface test actor, and right here where we inherit from a actor, we just put a comma, and it's going to be public iInteraction interface that we created. Now it should, again, it auto included this for me, but if that doesn't happen for you, which I assume it won't, make sure you include the header for our interaction interface. And then we would just simply come down here now and override the functions that the interface declares. So I'm going to go generate overriding members. Now in Rider, this is really cool. If it inherits from multiple things, you have starting out a big list here. You can click this button to group, and now look, everything like engine related is down here, but here's my interface. So I have begin and end focus, and then I have all of the other ones too, right? Now it puts them in the header here, but it doesn't implement them. So I'm going to go back and say generate definitions, all of that. All right, looks good. So this is default stuff. You don't need anything inside of these yet. It just kind of assumes that it's going to make a call to a parent class. All right, so how are we going to do this? So what we're going to need is we're going to need a mesh on this actor because we want to be able to test the highlighting, right? The begin focus and the end focus. So we need to come over to the header file and we're going to add a static mesh component. So I'm not going to bother with cleaning this up too much just because it's just a test, but I am going to at least kind of delete some of the redundant public private stuff, public protected specifiers. Now if we can put this in protected. Just call it mesh. It's going to be a U property because we're going to edit this in the editor. It can be edited anywhere. Test actor. Yeah, that's fine for a category. Okay, so all we really need is this mesh, because the way line traces work is they trigger when they trigger a blocking hit, to say, okay, I've hit something, that triggers off of a collision volume. And we're just going to use like one of the built-in cubes or something in the engine, and those all have collision volumes already. And so then what we want to do is highlight the object. So to do that, there's something a little more unique, and it involves the mesh. So first what we want to do, come into the constructor, and we're going to say mesh is equal to create default subobject. It is a uStatic mesh component, and this is just the name, we can just call it mesh. Then we want to set root component to mesh. So that's done. Now we will essentially the point of the move widget and everything, it's going to consider that to be the root object of this whole actor to be that mesh. So that's what we want. Now here in begin focus, we're going to say, okay, if our mesh is valid, and this is really not too important in this actor because we know we're going to set it, but this could be more, we'll do this again in the pickup, excuse me, in the pickup class, where it might be, there might be a reason why it doesn't get the mesh off the data table, because that's where we're going to be pulling this from on the pickups. We want to call a function called setRenderCustomDepth, and it just takes in a Boolean, so we're going to set it to true. Likewise, in the end focus, we're going to set it to false, so just copy that. Now what this is, I'm going to have to show this when we get into the editor. We're going to configure it. There is essentially a render depth. I think it's either like a buffer or a layer. This is a little bit beyond me when it comes to like these rendering layers, but it's called custom because it allows you to set custom effects and custom kind of things that happen on that layer. And so what we're going to do is I have some materials that are already pre-made that will highlight the bounds of what you can see on a mesh. And when you turn this layer on, it sees that material and it applies it over top of the mesh to create the highlighting effect. I'll talk about that more when we get back into the editor. So the only thing left to do is, so this will be easily, this is how we easily see, okay, is the focus working? If it highlights, if it unhighlights. For begin interact, we can just put some logs in here for now. We'll just put some log temp warning, and we can just say calling begin interact override on test actor, on interface test actor. Do the same thing down here for these guys. Calling end interact, and then calling interact. right? Because it doesn't really matter what this is doing. We just want to see something happening. I think that should be it. It's very basic. Again, this is just a test actor. We're going to delete this later on. So I'm going to go ahead and build and reopen the editor. Okay, I've got the editor back open. Now I'm going to go in here and you'll see I have a folder I called materials, and it's got these two materials, this outline custom depth. Okay. And so what these do is, this is something that not this one, this one. I am not knowledgeable about the way these it's like essentially shader math. This thing is massive. I found this in another course or in another project somewhere, and I basically stole it. But I believe, from my experience in Unreal Engine, this is kind of a common implementation of how this is done. I watched a video about it, and there's videos out there that will teach you how to build this. But what it does is you can see there's like these labels they put for like top, left, bottom. It looks at the extent of the space on the screen that this actor takes up, or the mesh takes up, and then it allows it to kind of mask that out and then apply some stuff to that. One of the main things being an outline and a color here. And so if you want to change the color of your highlighting, you can actually come in here and tweak this. But now how do we apply this? So what we need to do, we need to find the world settings. Okay, so I paused for a minute there because it's been a little while since I tweaked this and I kind of forgot. It's not under world settings at all. It's under the post-process volume, right? Because this stuff is considered post-processing. So this is it just sits in your level, and it can be set to, where's it at? There's a way to set this thing. Oh, here are details. Okay. So there's like an extent setting for a post-process volume to basically be infinite. And that's what they've done here, because you can customize it, right? You can have a specific area get post-processing, in which case it would just be the contents of the cube, or you can set it to unbounded, and then at that point it covers the entire game world with just, no matter how big it is. And so I was trying to find that, and there's just so much stuff in here. Yeah, so I'm just filtering it. So it's under the volume settings, infinite extent, unbounded, right? So whether this covers the whole world or just the area inside. So obviously by default that is checked. Now what we want to find is the custom, oh man, all right, hold on. All right, it's under rendering features, post-process materials, and then there's an array here, okay? So what we want to do is we want to add an asset reference, and for that asset, I don't remember why these things were called PP at the front. It's probably just a naming convention for something to do with shaders. But we want to add in the custom depth instance. Okay? Now save that. Now let's create a blueprint off of our interface test actor. Create blueprint class based on this, and I'm going to put it under my blueprints. So BP interface test actor. All right, so it opens up and it's completely empty except we have a mesh, and so we will just put in, oh yeah, I added in those Infinity Blade assets. Yeah, let's use an armor suit. That's cool. So now I'm going to open up and find that, drag it in, make sure that it looks okay. All right, and now let's try this out. So now what we expect, oh, he's a little short, isn't he? There we go. Now what we expect to happen is once this line trace hits this, it will highlight. It did not work. So let me sort this out really quick. Okay, so I sorted it out, and the mistake I made was I chose the wrong material. So do not choose the material instance, choose the material itself. And I forgot to mention this. I'm going to put these on in Google Drive and make them available to download in the description of this video. So I'm sorry, I should have mentioned that a bit earlier. So now when we look, you can see we get the nice highlight as if this were an interactable. So the render depth, the custom render depth is working well. And thanks to whoever it was that built that shader, because you saved a huge amount of work for many people. Now, I put those logs in there because I wanted to test the interaction. But now how do we do that? Well, another sort of mistake I made, not really a bad mistake, just being a little hasty. Let me save my world here. I'm closing the editor. We have functions for interacting, but we have no way to actually interact. We have no button or anything, right, to interact. And the reason is because I didn't actually bind anything. So what I'm going to do, we're going to add some bindings here. So we're going to bind an action because it's just going to be like a single key with a press and release similar to jump. This is going to be interact. When it is pressed, we want to call a CS Tutorials character, not interact, but begin interact. And likewise, copy this and now change this to released, and you guessed it, end interact. Okay, so Writer's kind of just trying to be helpful here. It's like, hey, this isn't bound. So we're going to relaunch the editor and bind that, because that is something you bind in the editor kind of on the fly, and it doesn't require compilation. So I'm going to relaunch. Okay, so now we're in here. We want to have that button bound. So you go to Edit, Project Settings. Over on the left, come down to Engine Input right here. And now you can see we've got all of our different stuff that came in this project by default, which is just, again, the default third-person project. So action mappings. Add a new one. Interact. And now you can press this and just hit the key you want, or you can choose it from a giant list. So I'm just going to hit this, E. Now I'm okay with using E. You can add another one here and say you want to bind it to like your gamepad or something if you want to play this with a controller. This is where you'd add two, because if you see, they did that here, right? They have a gamepad binding and then two keyboard bindings for forward and backward, and then it uses the Y-axis on the thumbstick. So if you want multiple things or just a different key, change that. But otherwise, this is like linked to like an XML or something in the background. So all you do is when you add something here and kind of like click away, it's saved. So all you gotta do is close it. Now, what we expect to see right down here in the log, when I highlight this and hit E, there you go. That is the interface in action. We called begin interact, followed by interact, and then lastly end when I let go of the key. So now if I hold the key, right, you see we've called begin and then interact, and then I let go, end. Because we only call the end function when the key is on the release trigger. So there we go. So I think that wraps up the crucial parts of the interaction interface. Now what's really great about this now, getting this out of the way, is that we can take this, we're going to add a few refinements here and there, but for the most part this is done. And now this opens the way to building the inventory itself, followed by pickups. And that's what's really important about the interaction, is that we can now walk up to a pickup, we can see it highlight, we can press E on it and run custom functionality that will allow the pickup to be added to the inventory and removed from the world. And then likewise, we can, later on drag it out, throw it back into the world, pick it up again, the whole 9 yards. So that wraps up this whole interaction interface section, and we'll pick it back up in the next video with the inventory, starting out with the inventory.